Eric, and in this video I'm going to show you how to do practical work in QGIS using map projections and coordinate reference systems. Before starting there, a short introduction. Everywhere in the world, all countries have their own map projections. That is because the Earth, of course, is not flat. In order to get the best flat map, well, it takes some work, as you can see by the way this orange is being peeled. There's a very good explainer on YouTube by Vox. The title is Why All World Maps Are Wrong. This will explain why it is so hard to map the world as a whole. For now, we're using QGIS, and there's just 3 coordinate systems that you really have to know about. That is the Dutch Rijksdriehoekstelsel, the coordinate system of the Netherlands. That is the one we're using most in the Netherlands. And then there's 2 international ones. There's what we call the GPS coordinates, World Geodetic System, 4326, that is being coded. And that will give you just the latitude and longitude on a rectangular grid. The pseudo-Mercator was introduced by Google to the world in its product Google Maps. So that is by now probably the most widely used map projection in the world, because everyone online uses that one. Without further ado, let's have a look at how this works out in QGIS. You might be wondering what kind of a distorted world map this is. And it is distorted, and it is because of the projection. What we've set here is the projection for the Dutch coordinate system. Here in the bottom you can see EPSG code 28992, which is the Dutch coordinate system. That means that in the area of the Netherlands, this one works perfectly, but on a world scale it is terrible. The further you get away from the Netherlands, the more distorted it becomes. So depending on what area of the world you want to look at, you can pick another projection for your map. In this case, we've picked the wrong one, but for example, let's say that you're interested in looking at the world in a kind of a Mercator way. This is the projection that, for example, Google Maps uses. It's not perfect because, for example, the size of Greenland here is totally wrong. It looks to match the size of Africa, and in fact, of course, it doesn't. Another way of looking at the world is through, in this case, the World Geodetic System. So if you use a projection that is basically not a projection, but just putting all your lat long coordinates on a squared area, it looks more like this. Now from a world point of view, this one looks good, but if I zoom into the Netherlands again, you see that the Netherlands itself it looks a bit skewed. So depending on what part of the world you want to map, you have to pick the right coordinate system. In this case, if you're looking at the Netherlands, I would go for the Dutch coordinate system. You might have noticed that QGIS reprojects the data on the fly. So if we change the coordinate system of the map, the data changes shape. Now that sounds logical, but that means that QGIS has to know which data is in the map. And the world map in this case has its own coordinate system. When QGIS knows the coordinate system of this data set, it can reproject. Otherwise, it will mess up. I'm going to show a few examples of how this is being messed up. In this example, I made a very common mistake. This happens a lot when you do something wrong with coordinate systems. This place is where a lot of Dutch data ends up. It is where both x and y are around 0 in the Dutch coordinate system. Okay, so what happened? If I look at the track that I loaded, and I zoom to layer, you can see the whole track is there. However, if you look at the coordinate box here at the bottom, you can see that, well, it is 5 meters east and 52 meters north from the origin of the Dutch coordinate system. So you can also see that the scale, it's quite big. This is definitely something wrong. While loading these data set into QGIS, we've convinced QGIS that those were Dutch coordinates, so meters starting from the origin. Of course, this is wrong. Now let's have a look at the coordinate system. We can set a different coordinate system, the layer coordinate reference system. We see that it is now set to Amersfoort or Ardennes or 28992, but of course these are WGS 84 coordinates. If we zoom now to the area, we can see it's in the Netherlands. We can even have a look at a good background map to see if it is more or less correct. Well, that looks correct, as I remember having driven there. So if you look at coordinate systems in QGIS, there's two things you have to pay attention to. One is how to project the data in your map, and the second is for every data set here, it has to be defined as having the right coordinates. Now QGIS can reproject every coordinate system into every coordinate system, but it has to have a good basis to do that.